Alright, so for our lesson today, 5.4, our purpose statement is explain and describe the steps needed to complete the square in a quadratic function and write the quadratic function in vertex form. So we have a couple things we're going to do today. So what we've learned so far in this chapter is we worked with transformations of quadratics, and then we learned how to solve quadratics. We did one by graphing, and that's a method that's plausible, although it's hard to tell when they're not whole numbers, by making the charts. Then we did factoring. Factoring works great if the problem's factorable, but it's not always factorable. So completing the square is a method that will always work, and we'll have another method that we'll go to later on that always works, but completing the square is a good way to do it. So the square root property says if x squared equals a, and a is a non-negative real number, we won't deal with negatives yet, we'll get to that later, then x equals plus or minus the square root of a. So things you would know, if x squared equals 25, we know that x equals 5, or it could also be a negative 5. So we can just write that. So x equals 5 because 5 squared equals 25, or x equals negative 5 because negative 5 squared is also positive 25. The way we'll write that is we'll just do plus or minus. So plus or minus the square root of a, so we took plus or minus the square root of 25, which is 5. So that works. Now, how we're going to use that is in completing the square. So let's just do a problem as we go through this. Let's take x squared plus 6x minus 15 equals 0. So the first thing we're going to do always is write in the form of x squared plus bx equals c. Now, you'll notice there's not an a here. The value in front of the x squared always has to be 1. So in this case, we're okay. But you can see we just have the x's on this side, and the constant, or the number by itself, has to go to the other side. So the first thing I would do is add the 15 to the other side and get x equals 15. So that's step 1. Step 2 is we take half of b. Well, b again is the number multiplied to x, not the x squared, just the x. And so we take half of 6. And in this case, half of 6 would be 3. So that's easy. The third step is to square whatever we got for half of b. So now we have to take 3 squared, which is 9, and we have to add 9 to both sides of the equation. And so we get x squared plus 6x plus 9 equals, we add 9 to 15 and we get 24. Okay? Then we factor the perfect square. Now, here's the thing on this. We're putting it in this format for a reason. We could do the x method. We could put 9 up here and 6 down here, and the numbers that multiply together to give us 9, then add to 6 are 3 and 3. And so we would get x plus 3 times x plus 3 equals 24. But x plus 3 times x plus 3 could be written as x plus 3 squared equals 24. Well, the reason it's called a perfect square is because this always happens. And so what we'd like you to understand is that any time that we have a problem in the format of a squared plus 2ab plus b squared, that will always factor into a plus b squared. And if it's a squared minus 2ab plus b squared, it always factors into a minus b squared. All right? It happens when this middle term is double the square roots of these multiplied together. Well, that's what happens when we complete the square. We always get the square root of x squared is x, the square root of 9 is 3, and if you double that, you multiply them together, you get 3x, and double that, you get 6x. So we won't need to do the x method on these. We can just do this. The square root of the first, the sine of the middle, the square root of the last. And we'll always be able to do that. Now, some students have trouble understanding how we get from here to here, but if you think about this, x plus 3 squared is x plus 3 times x plus 3. And if I claw that, x times x is x squared, x times 3 is 3x, 3 times x is 3x, and 3 times 3 is 9, we get x squared plus 6x plus 9. So this is exactly the same value as that. It's just written differently. So that's completing the square. Let's do another one. Let's do one with a minus sign. Let's do x squared minus 12x plus 10 equals 0. So now, again, our first step is to write it in the correct form. So we move the 10 to the other side by subtracting it. We take half of 12. Now, it's half of negative 12 is negative 6, but we're going to square it anyway, so you're going to get rid of the negative sign, so don't worry about that. You can go negative 6 and square it, but either way you get 36. So we add 36 to this side, and we get 26. And so we get x, remember the square root of this, x, the sine of the middle, minus, the square root of 36 is 6. And we have completed the square and factored that. Now in a little bit we're going to get to where we solve this, but for right now let's just take it to this point. Alright? Now another thing they can do to throw you off, or make it more difficult, is to put a number in front of your x squared. So let's go like this. So again, we have to put it in this form. So we move the 5 to the other side. Now remember, there's no number in front of the x squared, so we have to get rid of this 4, and since it's multiplied, we have to divide everything by 4. So we get x squared plus 3x equals 5 fourths, because I divided, so I've gone through and I've divided everything by 4. So now we do the same thing. We take half of b. Well, now again, we have fractions here. So I would just, you can leave it as a fraction or you can do it as a decimal. That's your choice. I usually leave them as fractions because it's easier to square them. So we take 3 halves and we square it. So remember, you square the top and the bottom, 9 fourths. So we're going to add 9 fourths to both sides. So we have to add 9 fourths here, and we get 14 fourths. Square root of the first, sine of the middle, square root of the last. Remember, is that 3 halves. And 14 fourths reduces to 7 halves. And so we've just gone through right now and we've completed the square. Now we're going to go on to solving this. And so we have some other steps to go through to solve it. So we're going to continue on with this problem and we're going to solve by completing the square. So our first step is to complete the square. That's what we've already done. So we took the problem, which was 4x squared plus 12x minus 5. And we factored it, we completed the square, and we got it down to this. X plus 3 halves squared equals 7 halves. So we did the work to get down to here by completing the square. This is our 4 steps from up here. So after we do that, we've completed the square. This is where we use the square root property. That says we can take, if we have something squared, we can take the square root of both sides. So all I'm going to do is take the square root of both sides. And what this does, just like when you get rid of the 4, you divide, you do the opposite operation. Squared and square roots cancel. And so this becomes x plus 3 halves, because the square root and square cancel, equals plus or minus the square root of 7 halves. So we've done that, we've taken the square root, and lastly, we solve for the variable. So to get rid of plus 3 halves, we subtract. Now, you can put it after it. Most of the time, the book will write it in front, so they'll just put, since it's minus, they'll put a negative 3 halves, plus or minus the square root of 7 halves. And now we've finished the problem. So let's go through 2 more problems. These would go on your paper, your half sheet that you turn in with your objectives. So, example number 1, we'll do this one. So let's follow the steps. We complete the square. So again, we have to put it in the correct form. So we move the 20 to the other side. X squared plus 12x equals 20. We take half of b. Half of 12 is 6. 6 squared is 36. So we add 36 to both sides. So we get 56. Now it's a perfect square. So to factor that, again, you can use the x method, but square root of x squared is x. Sign in the middle is positive. Square root of 36 is 6. And then we take the square root of both sides. So we get x plus 6 equals plus or minus the square root of 56. And subtract 6. Now, one last thing on this is that we have a square root of 56. I won't take off right now. Later on, you may have learned how to reduce in algebra or geometry. We'll go over this later. But for right now, you can leave it this way. But the thing to recognize is the square root of 56 can be broken down into the square root of 4 times the square root of 14. And the square root of 4 is 2. So the answer the book might have would be that. So be careful, understand that you can reduce these and the book will have them reduced if you don't. All right, so let's do example number 2, where a is not equal to 1. So we do the same thing. Move the 15 to the other side. Divide everything by 2. So that becomes 15 halves. Again, all I did was divided each of these by 2. Then we have to take half of 4. Half of 4 is 2. Square that, which is 4. And so we add 4 to both sides. Now, with a fraction, we're going to add 4. So to add fractions, we have to have a common denominator. So I'm going to change this into halves. So remember, to change whatever you have to multiply the denominator by, you multiply the numerator by the same thing. So 1 times 2 gives me 2. So 2 times 4 gives me 8. And so 15 plus 8 is 23. And the denominator stays the same. So we get 23 halves. We've completed the square. So it's the square root of the first, sign in the middle, square root of the last. Then we take the square root of both sides. So the square root and squared cancel. So I just get x plus 2 equals plus or minus the square root of 23 halves. And then we move the 2 over and we subtract 2. Negative 2 plus or minus the square root of 23 halves. And we're done. So that's the majority of the assignment, is completing the square and finding the answers. They are going to ask you to put some of these answers in vertex form. And that is less work than what we just did. So to put it in vertex form, all we do is take the problem and we complete the square, just like we've been doing. So we move the 25 to the other side. So we get x squared minus 12x equals 25. Half of 12 is 6. 6 squared is 36. So x squared minus 12x plus 36. So we add 36 there and we get 61. Now we've completed the square. X, middle term is minus, so minus. Square root of 36 is 6. And remember, vertex form is a times h minus k, excuse me, a times x minus h squared plus k is our function, or in this case equal to 0. All we do is we move the 61 back. X minus 6 squared equals 61, excuse me, by subtracting it, so minus 61. And we've got it in vertex form. So our vertex is h, the opposite of that, so 6, negative 61. And that's all you're doing for vertex form. So your assignment for 5-4 is page 345, numbers 21 to 37, the odds, and 41 to 59, the odds. So make sure you follow the steps closely. And if you just follow each step as you go, hopefully you won't have too much trouble with that.